Imagine you step outside tonight. You look up, searching for that familiar silver disk, but it is not there. The sky is a deep, unbroken black, punctuated only by the sharp, distant glint of stars. The moon is gone. The world does not end in a flash of light or a great cataclysm. The sun will still rise tomorrow. The birds will still sing. But something fundamental has shifted. A silent partner in our planet's long dance through space has simply vanished, and the world we know will begin to change in ways both subtle and profound. This is not a story of disaster, but a quiet exploration of connection. This thought experiment invites us to consider our nearest celestial neighbor not just as a pretty light in the sky, but as an active participant in Earth's systems. For all of human history, and for billions of years before, the moon has been a constant presence. It has pulled on our oceans, stabilized our planet's rotation, and illuminated the darkness for countless generations of life. Its sudden absence would be felt first as a deep, psychological void. Poets, lovers, farmers, sailors would all feel the loss of a timeless anchor, a shared point of reference that has woven itself into the very fabric of our culture and consciousness. What would we truly lose if the moon disappeared? The question leads us down a path of scientific discovery. Let's begin this journey calmly, with curiosity as our guide. We won't focus on impossible scenarios or wild speculation. Instead, we will look at the real, scientifically understood consequences of such a monumental event. The very first change would be simple and absolute. Nights would become profoundly dark. On a clear night, a full moon can be thousands of times brighter than the next brightest object, Venus. Its gentle reflected sunlight bathes the landscape, shapes, shadows, pathways. Without it, the night would return to a primordial blackness known only to our most distant ancestors. The only natural light would come from the faint glow of the Milky Way and the pinpricks of starlight, which cast almost no discernible light on the ground. Rural areas and vast wildernesses would be plunged into an ink-black darkness, a world known only by sound and touch. In cities, our own artificial lights would overpower the darkness, and many urban dwellers might not notice the change at first. But for anyone living away from the glare of streetlights, the change would be immediate and stark. Nighttime activities that rely on moonlight, from farming, fishing, simple travel, would become far more difficult. We would become more dependent on artificial light than ever before. Without the moon, nights would be much darker. And honestly, the werewolves could finally get some rest. This new, deeper darkness would also change our relationship with the stars. With no moonlight to wash out the fainter objects, the night sky would become a breathtaking spectacle. The Milky Way, a brilliant, textured river of light, thick with dust lanes and nebulae. Distant galaxies and star clusters might become faintly visible to the naked eye. Our cosmic neighborhood would feel both emptier and infinitely larger at the same time. This loss of light is more than just an inconvenience. It would have a direct impact on the natural world. Many nocturnal animals, owls, moths, big cats, have evolved to hunt and navigate using the soft glow of moonlight. Their eyes are adapted to low light, but even they would be challenged. Predators might find it harder to spot prey, and prey harder to spot predators. The delicate balance of the nighttime ecosystem would be disrupted, forcing countless species to adapt or perish. The most significant physical change, and one that would be noticed within hours, would be to our ocean tides. The rhythmic rise and fall along our coasts is caused by the gravitational pull of the moon and of the sun. The moon, being so much closer, exerts about twice the influence. If the moon vanished, the tides would not disappear. The sun's gravity would still create smaller tides, about one-third the height we experience today. This reduction would have massive consequences for coastal ecosystems around the globe. The vast intertidal zones, areas exposed at low tide and submerged at high tide, would shrink dramatically. These zones are rich with life: barnacles, mussels, sea stars, crabs. Many habitats would become permanently submerged or permanently dry. Tide pools, once common, would become rare. This change would ripple up the food chain. Birds, fish, and marine mammals depend on the intertidal zone for food. Tidal mixing transports nutrients and oxygen. It fuels phytoplankton, the base of the marine food web. Weaker tides mean slower circulation, lower productivity, and impacts on fisheries. Human coastal infrastructure, harbors, ports, shipping channels, are designed for specific tidal ranges. A sudden permanent shift would need massive re-engineering and dredging. Tidal power communities would lose a resource. Some low-lying areas might see temporary relief. The entire rhythm of coastal life would be fundamentally and permanently altered by the silencing of the moon's gravitational pulse. The moon does more than pull on our oceans. It also acts as a gentle brake on the entire planet. As Earth spins, the tidal bulge created by the moon's gravity drags slightly against the planet's rotation. This friction is incredibly small, but over geological timescales it has gradually slowed Earth's rotation, making our days longer. Billions of years ago, a day on Earth was much shorter, perhaps only a few hours long. The moon still lengthens our day by about 1.8 milliseconds per century. If the moon vanished, this braking effect would stop immediately. The primary force slowing our planet would be gone. That doesn't mean days get shorter overnight. Earth has tremendous rotational momentum, like a massive spinning top. Without the moon, our day's length would become much more stable, changing only from much smaller effects like solar winds and atmospheric friction. The process is reciprocal. As the moon slows Earth's rotation, energy is transferred to the moon. It gains orbital energy and drifts away at about 3.8 centimeters per year. If the moon vanished, that outward spiral would end. The Earth-Moon partnership would be abruptly terminated. Earth would spin on its own, unburdened by its massive satellite. Immediate change would be imperceptible, but long-term evolution would be altered. The slow march toward longer days would stop. Earth's spin would then be governed by its own inertia and the much weaker pull of the sun. Perhaps the most serious long-term consequence of the moon's absence would be its effect on Earth's axial tilt. Our planet is tilted by about 23.5 degrees. This tilt gives us seasons: summer, fall, winter, spring. The moon's gravity acts like a stabilizing anchor, keeping the wobble constrained to a small, predictable range. Without the moon, Earth's axial tilt would become much more chaotic, tugged by other planets, particularly massive Jupiter and Saturn. Over tens of thousands to millions of years, the tilt could vary dramatically, from nearly 0 degrees, no seasons, to as much as 45 degrees or more. This is not a sudden event. It is a slow, creeping instability. Imagine a world where tilt rises to 45 degrees. Polar regions would receive intense summer sun. Temperate zones would swing to seasonal extremes. A city like Paris could experience summer temperatures hot enough to boil water, and winter temperatures far below freezing. Such drastic swings would challenge complex life, agriculture, and civilization as we know it. The moon's stabilization is a quiet gift, allowing complex life to evolve and flourish. Mars lacks a large moon. Scientists believe its tilt has varied wildly, contributing to dramatic climate changes. The moon is our silent guardian, preserving the climatic balance that makes our world habitable. The disappearance of the moon would disrupt ancient cycles and behaviors. Many species synchronize with the lunar cycle. Mass coral spawning, timed to nights after a full moon, could fall into disarray, threatening entire reef ecosystems. Sea turtles use moonlight to guide hatchlings to the sea. In a moonless world, they'd be disoriented, drawn inland to lights, caught by predators, or succumb to exhaustion. The tidal cycle is a dinner bell for coastal predators. Smaller solar tides mean less reliable food. Animals must adapt or decline. Even insects tune to lunar phases. Their changes affect bats, birds, and the plants they pollinate. Removing the moon is like removing the conductor from an orchestra. The music wouldn't stop, but its timing, harmony, structure would be broken. The moon is woven deeply into human culture. Its absence would leave a gaping hole in our collective psyche. We used it as a calendar, a clock, a source of myth. The word month comes from moon. Many traditions still follow lunar calendars. Easter, Ramadan, Chinese New Year. Our language and stories are filled with it. Once in a blue moon, honeymoons, lunatics, and it drove telescopes, rocketry, and the space race. Today, nations and private companies plan to return, build bases, use lunar resources, a stepping stone to Mars and beyond. Its sudden vanishing would be both a cultural and practical loss, removing the most logical, inspiring next step in our outward expansion. Amidst all this change, remember what would not happen. Earth would continue its yearly journey around the sun. Your weight wouldn't change. Our magnetosphere and weather engine, powered by the sun, would persist in the short term, much as before. To imagine a world without a moon is to appreciate its quiet, pervasive influence. The change would begin with a darker night and weaker tides, a simple subtraction that would immediately disrupt coastal ecosystems and the behaviors of countless animals. The familiar rise and fall of the ocean would soften to a whisper, reshaping our coastlines and the economies that depend on them. Our planet, freed from its gravitational brake, would cease its slow, steady lengthening of the day. Over much longer timescales, Earth's axis would begin a slow, chaotic wobble, leading to dramatic swings in our climate. Stable environments would tip into extremes, fundamentally altering conditions for life. The moon, it turns out, has been a silent guardian of our planet's stability, a gift we rarely acknowledge. Its loss would be deeply human, a symbol, a calendar, a muse, a scientific beacon, gone. Life would persist, it would adapt. But the world would become a stranger, quieter place under a sky filled only with distant, cold stars. We live in a system of intricate, delicate connections, where a massive ball of rock 239,000 miles away is essential to the rhythm of our oceans, the stability of our climate, and the history of life itself. The moon is not just a neighbor, it is a part of Earth. Its presence has sculpted our world into the home we know. In its imagined absence, we see its true importance. It forces us to look up and recognize a grand, interconnected cosmic dance. If we have learned to see so much of our world in the moon, how much of ourselves have we yet to discover in the stars beyond it?